Hello guys, welcome to Algorithms Made Easy. Today we will be discussing the question number of longest increasing subsequence. In this question we are given an integer array nums and then we need to return the number of longest increasing subsequences. This question is an extension to the problems which I would highly recommend you to solve first before solving this question. The questions are longest continuous increasing subsequence and longest increasing subsequence. It is an extension to this medium level problem. So now what this problem is all about. First example, we can see that the array is given to us. There exist two longest increasing subsequences of length 4, which is 1347 and 1357, and we need to return 2. And in the second case all the values are same, so we return 5 because the longest increasing subsequence is of length 1 and there are 5 such values. This question is an example of dynamic programming and we'll see how we can achieve it. In order to solve this question, we will take two arrays, length array which will hold the length of the sequence and then the count array which will hold the number of sequence ending with that particular number. We'll start off with the index 1 as the 0th value will be 1 1. We are initializing both the array with 1 as the length of any sequence is at least 1 and the count of any sequence will also be 1. We'll start off with value 3. So what we do is from every ith from 1 to n we will check from 0 to ith value and we check for all the values that are less than the ith value. So as we see that 1 is less than 3, so what we do is in this case we know that whatever sequence is ending with 1 can also be now incremented with one more length, that is 3, and the longest sequence will now become of length 2. So the length we added in the next, and now the count will be the same as 1 because the sequence is only 1. There is only one sequence ending with 3 right now. Now what we do is, let's fast forward this to the last element so that we can see that how the value of the count gets affected. Now for every value before 7 we will compare it and put that plus 1 of the length into the length of I. We will do this for all the values, and here at 5 we see that the value at the length is 3. So what we do is plus 1 and we put 4. Now we come to 4. Now here is the logic for count. Now what happens is we see that the length is already 4. Now even with the sequence ending with 4, the length will be equals to 4. That means there are two different sequences that are ending with 7 that have the length as 4. So what we do in this case is we put all the values, all the sequences that are ending with 4 into 7 because they will in turn create a more longer sequence with the help of 4. So what we do is we add all the count values of 4 into 7 and that gives us 2. Now there will be a variable which will take the maximum of length and we iterate over the array finding if any length is equals to the max length, and whatever values are there will put all the counts into a variable and then return it. That will be our answer. So let's code now. As we always check for an empty array, we first check for it, and if the length is equals to 0 then we simply return 0. So as we will be using length quite often, we will take that into a variable, and then we take two arrays, the length array that we discussed of length n and then a count array. We'll fill both these array with the default value of 1. And then we have a max length variable initialized with 1. Now as we know, we will loop from int I from 1 to the n value. Now for each of these we need to have a jth starting from up till the ith position. We first check if the value at ith position is greater than the jth. That means the sequence will be increasing. Now we check if the length of the j plus 1 is greater than the length at I. This shows that the length will increase and the sequence now created will be much longer. So what we will do is we will put the length of j plus 1 into I, and the count of all the values of I will be is equals to count of j. Now the condition where if the length of j plus 1 is already equals to I, that means it is a different sequence that comes into picture. So what we will do in this case, we will just add all the values of count j into count I. Now after this loop we need to take care of the max length, that is by taking the math.max of the max length and the length of ith position. Once this is done, we will simply take a variable result which is equals to 0, and then we loop from I0 to I to n plus plus. Now if the length of I is equals to max of length, then we simply add the value of count into our result variable, and at the end we simply return our result. Now let's test this code. Okay. So it is giving right result. Now let's test this for the second example. It is also giving the right result. Let's submit this. So we are getting the right result. Now this solution is O of n square complexity and can now further optimize to have a complexity of O of n log n by use of binary search. I would recommend you to try that once. Let me know in the comment section if you face any issue. Thanks for watching. See you in the next one.